Alright, so just a quick recap on what we've done the past couple of lessons to help lead us into what we're doing today. So I'm looking at page 93 in your notes. So property number 1. So equal arcs on circles of equal radii will subtend, okay, subtend mean form, equal angles at the centre. Okay, so basically you have we haven't done that's not second one. Basically, if you've got the same circle, two circles, same radius, they'll form the same arc, the same angle if the arc lengths are equal in each of those circles. Alright, so moving along to the second one. So that's equal chords. Okay, so a chord is circumference to circumference. It doesn't go through the diameter, so it doesn't go through the centre to be the diameter, is a chord. So equal chords will subtend equal angles. So if we have two chords that are equal in length, we join them up to the centre from the end point. That will also mean that centre angle is also equal in size. And we've done a triple S test on congruent triangle proof, and then we match those two angles with those two triangles. Right, the converse is also true. So if you have two angles at the centre that are equal, you draw the radius out to the circumference, you join them up to form some chords. Those chords will also be equal in length. And that was the second part of that second property. So similar are congruent triangle proofs, setting up the side, angle, side. Remember, whenever we show the side, angle, side, we'll cover this more in mathematics. We are always having the included angle between those two sides. You can't just have any two sides and not the included angle is not enough to show congruence. Alright, third one. This is one of the more common ones, the property on page 3. So the angle at the centre of the circle is twice the angle at the circumference. So basically at the end of the last lesson I got you to draw some examples. So we had drew a circle, centre point, radii out, then we picked another point on circumference and we joined the end of the radii to that point on the circumference. So this angle formed by the radii is double the angle that gets formed at the circumference, and that will work for any instant. So that was a quick recap on what was done last lesson. So these videos have been uploaded. I've already uploaded yesterday's lesson on that group. Okay, so if you need to go through those proofs again, please make sure you're grabbing that group code. I've only got a couple of people joined in the mathematics group that I've seen so far. Okay, these videos are up there for your benefit. Okay, so if you need to go through a theory lesson again, or if you were absent, okay, you've got the opportunity to actually go through and have a look at the videos, not just rely on what I can give you here. Alright, so that's something I'm doing to help you. Alright, so today, Alright, so we're looking at page 95 in your notes. So your extension note and your mathematics notes are all in the one document. Okay, so it'll be all your mathematics notes first and then your extension. Okay, so when it's page 95, it's not page 95 of your extension note, it is page 95 of your mathematics and extension note. Okay, so as you go through the topic, I'll give you all the things, and then at the end of the course, you'll have a 120-page booklet to keep. Okay. Do what you want with it when you finish it. Frame it, put it on the fridge, whatever.
I'm going to do that now.
Yeah, Michael, I'll have to find some room for a couple of very good test results in the fridge to put the documents up. Alright, so number 4. So, angles in the same segment. I should have brought my notes. Alright, so looking at the, do I have it? Nope. Alright, so number 4, so in the box number 4, so angles in the same segment are equal. So if you're looking at your diagram there on page 95, okay, my maths teacher when I when I did it at high school, she used to call these butterfly wings because that's what they look like. Okay, so I will, just out of habit, I will refer to them as butterfly wings. Alright, so if I refer to that, we are looking at this specific property. So that means the tips, the same tips, so either the top or the bottom, they are equal sized angles. Okay, so basically we draw any two chords inside the circle. Okay, so let's have a go. Right, draw a circle. The centre.
That's a good.
Don't add to it, I'm not going to do any pokeballs there. Right, draw any two chords. The chord is end to end of the circumference that doesn't go through the centre to be a diameter. Okay, now I want you to go from the end point of the chord and cross it over with the top of the other one and vice versa. Okay, so you've created a set of a butterfly there looking thing. That means these angles here at the bottom, tips. So when we refer to a segment, we are referring to the arc here in that same segment. And likewise, up the top, these two angles will also be equal. Okay, when we refer to the same segment, we are referring to that arc there. Okay, so whatever you've drawn, okay, they will always be equal when you follow those properties. Alright, let's have a look at proof. Okay, so it is a requirement in your syllabus, in what I teach you, that you are familiar with the proofs, because the typical questions you'll be asked in your exams will be deductive reasoning. Okay, so in other words, you're doing something similar on the lines to congruent triangle proofs. Okay, you're deducing properties that are equal or similar to show that the overall property, what you're going to show, are the same. Right, so proof 9.4. Okay, so this diagram is in your notes there. Right, so the first thing we need to do is state anything that I produce on the diagram. Okay, so in this case it will be the dotted line. So the first thing you need to state is anything you've added to your diagrams. Right, so AO and OB are produced. Okay, so we're looking at the butterfly wings that we've got already. But in order to prove that these two angles at C and D are equal, and also at CAD and angle CBD are also equal. Right, so let angle AOB, we're going to call it X. Okay, not X, 2X. Alright, so that data alone there should tell you how we're going to progress with this proof. What I've done when I've produced AO and OB, I've produced the radii of the circle. Okay, so that was that property that we've done before. So we draw two radii. We then draw the end point of the radii to a common point on the circumference, and that goes with the property that the angle at the centre is twice the angle at circumference. Okay, so angle ACB. Okay, so when we are deductive reasoning or proving, we need to state a reason each step. So this one's what we did yesterday. So angle at centre is twice angle at circumference. Alright, so we've said this here is 2x, we've said this is x. Okay, again, radii out, we picked a new common point D on the circumference. We've joined the end of the radius of each side up to that common point. I mean, this angle here is also going to be x for the same reason as the other one. So angle, let's make sure we're notating angles correctly. The middle letter of the vertex, ADB, or BDA. It also equals x. Right, reason as above. Right, so I've already stated that reason. I'm not going to have to write the whole thing out again. Therefore, angle ACB equals angle ADB. So therefore, angles in same segment. Are equal. Alright, so we're not going to go through the other way, but just to show you. Alright, so if I do the reflex angle around here, and I'll call that 2y for example, I can then use that property to show that these two angles here and here will be y. Or I do my radius and I do it up to these 2 points here. So I've got that line down there and there already. And that will be a very similar setup to our proof there. Okay, questions?
Oh, yes.
Right, number 5. So, the angle in a semicircle with the right angle. So, a semicircle is where you use the hypotenuse of a triangle as the diameter, or use the diameter as the hypotenuse of a triangle. And the angle opposite the hypotenuse is the right angle. That will work in all triangles. So, your circle, centre point, another pokeball. Okay, so draw a diameter anywhere through the centre, anywhere you want. Alright, so I'm going to do it like this. Right, pick any point on the circumference, not too close to the endpoints of the diameter though. Any point on the circumference, not too close to the diameter. So here for example, then I want you to join the ends of the diameter up to that point. depending on your accuracy, the angle there should be looking pretty close to a right angle. Right, have another go. Draw another circle. Center point. Do a diameter. Pick a point on the circumference, not too close. And then join them up with the diameter. Okay, so what we're about to show is these two angles here are right angles. Okay, let's prove it. Are the converse also true? So if a triangle has a right angle, then the hypotenuse of that triangle will form the diameter of the circle. Alright, proof. 1.5.
These proofs are okay. The polynomial proof wasn't okay.
Yeah, I didn't even do a couple of them. Lucky. Alright. Okay, here's how am I going to prove that the angle at ACB opposite the hypotenuse, how am I going to prove that's the right angle?
Using the RH, where is it? RHS one?
Well, there's only one triangle there, so I'm not going to do a congruent proof. There's only one triangle.
180 degrees flat.
So you've got two angles.
You've got 180 degrees and you
Is
have
it's
to have
angle?
you have to have the 90 degrees to make it all.
Yeah, because
Angle.
I need a reason.
The triangle is always 180 degrees.
What's it?
So how are you going to prove the other two angles though?
The right angle one. What's it called?
Hey?
The right angle one.
If you're going to say RHS, I've already said it, that doesn't work.
Angle side.
We can't use the congruence proof because there's only one triangle.
Side angle quiet.
Now this is one of the things that only takes one thing to do to show that it's a right angle.
Draw the square.
What's in your mind?
Because those two angles equal 180.
They're both the same.
Both have to be 45.
Not necessarily.
So that one's-
Maybe,
that one's 39.
One has to be 9.
Wow, I'm a bit surprised actually. I thought this was jumping out at people already.
I'm really tired.
Alright, what am I drawing here? What's that called?
Radius.
What's this called?
A radius.
Does that give you a hint?
The. I'm really tired.
What's this called? Chord? What's this called?
X equals 2x.
Yeah, because?
Because it's touching the thing and then there's the two.
Okay, it is the angle at centre is twice the angle at the circumference.
Hey.
Oh, wow. Oh, wow.
I know. I'm shocked. So, that's what I've been saying. When we have the radius, two radii drawn, at the end we pick a common point on the circumference, we join the end of the radii up to that common point, alright? The angle at the centre is always twice the angle at the circumference. So, nice and simple. Angle ACB, or you can have angle BCA. Okay, must equal 90 degrees.
Why?
Angle is twice. This is one of the properties that will show up time and time again, okay? So we need to make sure we know what it is and how to apply it. Okay, so there's the right angle there, poorly drawn, but that's where it is.
Oh, here comes you.
Okay, so remember semicircle is half circle, so that means we are using the diameter as the hypotenuse, has to be the diameter, in order for the opposite angle to be the right angle. So therefore, angle in semicircle is a right angle.
Not double. No, put it like this. Ah.
Okay, it's easy now, I'll just pick up again soon enough.
So Snowy said he thinks he might be able to play him with that. And you might play him so he couldn't go and play.
I know he really wants to.
Well, we do need it.
I really want him to as well.
Everyone really wants him to.
So we go.
I went to that sushi trip.
Oh, Miss Mello, run. Blood, she's late, so.
So
Yeah.
weird.
Okay,
I'd come-
any question? We all see the property now? Yes, now that it's there, it's obvious, it jumps out, you're seeing it? Okay, let's have a look at some questions. So what's going to, your exercises are primarily going to be based to finding values of pronumerals, so missing side, missing angle. What we are going to lead into eventually is proving different angles are equal or different sides are equal, etc., or sides are parallel. That's what we're leading into, okay? So we need to make sure we are having a good grasp of the concepts in the exercises, and that will help you to identify things when we lead into proofs. Examples. Hey. Okay, find the length of chord PQ. What's the length?
8 centimetres.
Okay, PQ. 8 centimetres. Okay, what I want you to do in each of these questions, I don't think it says so in your exercises, I want you to actually state the reason. Alright, so equal chords. Produce so something along the lines of, while we're getting our heads around these first, equal angles at centre. So it may not quite be what I have stated in the property. But if you, I would like you to do this, because what will happen is if you do this and you're actually remembering the wording when we do our reasoning, you're going to find when we do the deductive part of it, it's going to be much easier. Okay. B. Down the page, find the value of x. Okay, so angle at centre is twice angle at circumference. Okay, so the angle at the circumference is the smaller angle. The angle at the centre is the larger one. Okay, so x is going to be 2 lots of 35. You don't need to show that working, but we just need to remember it's double. That's why I've written it there. X, and we need to state degrees. Okay, because we are referencing an angle. Right, quick reason, so angle at centre is twice
C.
Okay, so each question you do in the textbook, state a quick reason why, please. I won't deem it incomplete if you don't write it when you hand your exercises in. However, you will find it much easier when we move on to the deductive proofs that we need to do. More likely to recall and remember them. Right, C. Find the value of x.
Which one do we use to do that? The butterfly rate.
Will we use like a common triangle which
So?
is Z?
There, that's what I'm about to draw. Okay, so that's centre point. Now, so at the centre point I have two radii, like that. At the end, so I picked another common point over here. At the end of the two radii, I have drawn the chord. Okay, so that follows that property. Right, two radii, common point, chord to the end of the radii. So this is 40 here and x here. That's the angle at the centre, that's the angle at the circumference.
Ah,
Alright,
wow.
that's what I'm saying, it looks different to what we're used to seeing. That's why I'm stating the process so that you can follow it. Okay, so you're identifying two radii, common point, chord drawn to the end of those radii, the property is the angle at the centre is twice the angle at the circumference. So the angle at the circumference is the smaller angle. Okay, so x is going to be 40 divided by 2. You don't need to go 40 divided by 2. I'm just showing you that's the process you need to be thinking.
So is it week 6 or 7? Seven, yeah.
Oh no! Oh no!
What? Oh shit. It's like, who's done their chemistry assignment is due Friday next week. Yep, who started at 1:30?
I'm starting off. I
Yeah,
have
of course,
like 10 sources.
Yep.
Probably.
Alright, couple more. D. What property does it look like it's trying to show you? The butterfly wings. Okay, so angles in the same segment are equal. Alright, so the arc that's formed at the top here, that's the segment reference. So the same ends of the butterfly tips are equal. So x equals 60 degrees. Angle in
Y equals 120.
are equal. And what about y? Same thing?
Yep.
Alright, so we've drawn two chords and then we have crossed the endpoints of those two chords to the other end of the opposite chord. So y will be 120 degrees. Reason as above. Alright, E. Find the size of angle MQP.
It's 90 degrees.
Why?
Because if you look at P, it's not on the board. P is 90 degrees, and it's on the circumference, which means O has to be 180 when it is on the circumference.
Can I show you all something? Okay. When we do these sort of questions in your theory and your assessments as well, okay, one very good strategy you can do is you can redraw your diagrams. Okay, what happens when you redraw your diagrams, it might help you to find some values. So, we've got a Q out here, we need to find angle MQP. We need to find that angle there. And I'm looking at my diagram and I'm saying, what else can I add that doesn't give me give me more information than what I need? So if I put that diameter there, I can stop there because I have actually taken stuff away from the diagram that's been shown to me, and that might help you see a bit more obvious what things you need to do to find your answer. Okay, so there will be in diagrams, there will be things there to deceive you. Without looking at that, looking like we're looking a fair bit there, but I've actually simplified it, okay? Taken away the tangent, taken away all those other chords, and it's actually quite straightforward because we've got the diameter and we've got the angle in here. Angle MQP is the right angle, 90 degrees. The reason, angle in semicircle are the right angle. Okay, or you can say angle at centre is twice angle at circumference if you wish. Alright, so that's now the first exercise in chapter 9 can be attempted.
Oh boy.
Okay, so extension task due on Wednesday, mathematics today. You have about 17 minutes if you would like to use some time now to get some work done, or if you feel like you've had enough. You can stop there for today.